Hello all, in the last video we have reached this step where we have to check the value of count. So this count will help us to count the number of steps, and it will be in the start it will be assigned the value which is equal to the total number of bits, and with every step we have to decrement this value and then carry out this process, and we have to stop when count becomes equal to 0. Okay, so the moment count is equal to 0 means we are done with all the bits, and then we have to stop. Alright, now we will apply this Booth algorithm on this example where we are multiplying two positive numbers, that is 7 and 3, and we know that the 7 is our multiplicand and our 3 is the multiplier. So here we have 7 into 3, and we'll be using 4-bit size. That means we will have 4 bits to represent the numbers. Okay, and as we have seen in our flowchart, BR and QR. So here in BR we will put the first value, which is 7, and binary equivalent is 0 1 1 1. This you can check yourself also. Similarly 3, this value, the second value, will go to QR. The value is 0 0 1 1. Now the BR is this much, and if you go to this flowchart step, then focus on this one, this particular step where we have to perform a subtraction AC minus BR, and we know that we cannot do directly the subtraction, and hence we are utilizing this step to achieve subtraction. We are finding the 2's complement, so that we will do before we start the algorithm so that everything is ready. So we do that, we have the value of BR, and then we know that we have to find the complement, 2's complement. So we'll start with that. 2's complement is represented like this, and to find 2's complement we have this step that first we have to find the 1's complement, and 1's complement of this value will be reverse or inverse of each bit. So 0 becomes 1, and the remaining 3 bits, because it is 1, will now become 0. This we can check in your previous notes also, how to find 1's complement. And after finding 1's complement, we just have to add plus 1. So after adding this value, we will get 1 0 0 1. Okay, so this is our 2's complement BR, and this we will need when we have to do the subtraction. That means this particular step. Okay, and this we have to perform when the Qn and Qn plus 1 is equal to 1 0. So let's come back here and work out the example. So we are ready with these values, BR value and 2's complement of BR, and then QR. QR we are doing nothing, just keeping the binary equivalent. So let us begin with how to find the product process. Alright, so we are maintaining a table here in which these are the different columns, Qn, Qn plus 1. So these are the bits that we will check. You can refer to this, Qn and Qn plus 1. Okay, this is very important. So that is why we are having a separate column for that. Alright, so here Qn the first bit, Qn plus 1 the second bit, and the third column is our action. Whatever we are performing, we'll jot it down here. The value of AC. Okay, AC, we know AC in this steps. These are the registers that we'll be using. So AC is there, Qn, BR, QR, and count, which we'll be writing as SC, sequence counter. Okay, so we have AC, then QR. QR is our multiplier. All right, so then we have Qn plus 1. This is another register holding 1 bit, and then we have the last count value, okay, which is our sequence counter. It will start with the total size of the bit. Okay, so let us begin, and the first step is to initialize. All right, so when we start, there's nothing in Qn and Qn plus 1. Okay, so we mentioned it here initially, or you can write initialization also. And before we start, we have to assign zeros to AC, and because it is 4-bit size, so we put 4 zeros. And QR we have to put multiplier, as you all know, so we'll pick up this value and we'll keep it here. Now very important here, from QR only we are going to get the value of Qn. Okay, so Qn is the last bit. That is why I have put this arrow. See, this is our Qn, and Qn plus 1 is another single bit, which again, because this is initialization, will assign 0. Okay, so Qn plus 1 starting is 0, and Qn is the last bit of QR. And then SC is 4. We all know, because 4-bit size. If it is 8-bit, you write here 8-bit. Okay, so 4. And this we have to decrement, and as we move from one step to another. Alright, so now let us begin. So these are the starting values. Now, let's check the values of Qn and Qn plus 1. So if you look carefully, you'll find Qn is 1 and Qn plus 1 is 0. So we jot that down, 1 and 0. And if you check your flow chart, you'll find that when you have the value 1 and 0, we have to perform this subtraction, which we carry out with the help of the complement. So let us do that here. All right. So 1 and 0. So that is why that subtraction. See, I've written it here. Whenever this is the case, we have to do AC minus BR. Okay. So I've written the step again. So AC. So what is the value of AC? All zeros. So we put that. And BR plus 1 complement, and we have added 1 also. So that is why we have done this before. Keep it ready. So this is the value 1, 0, 0, 1. So we take that and we add. Alright. So after adding, we get this 0 plus 1, 1, 0, 0, 0, 0, 0, 0 plus 1, 1. Okay. So our this step is over. The step mentioned in the flow chart. Alright. So after this step, we have done this step now. Then the next step is, take this arrow, come here. Here we have to do shifting. Now this is a common step. In every step we have to perform shifting. So here after subtraction, we will do shifting. Shifting of these things. AC, Qn and Qn plus 1. So let's come back here. So shifting. So this was the value of AC. So we'll shift it. Now how to shift? Shift right. So it will shift one place towards the right. So let us shift this 1, 0, 0, 1. Okay. So this value we have to shift. So we're starting with this. So what will be the first value in the first place? So this, please remember, we have to copy the same value. So here we are shifting 1. So you're putting same 1 in the first place. And then our actual shifting starts. Now 1 goes here. Next place. This 0 will go here. One place movement. This will go here. And the last bit, if you see, last bit of AC will go across. Shift. It will enter QR, first bit of the QR. So that is the shifting, okay. This 1 and this 0 will also shift. This 0 will also shift. The second bit will shift to the last bit of QR. So QR is getting updated, okay. And this, the last bit, will again go across. It will go to Qn plus 1. So this is our shifting done. So after this shifting, again we have to check the value of Qn and Qn plus 1. Obviously, it has changed after shifting. And now, our Qn is how much? I've pointed with the arrow. It is 1. And Qn plus 1 is 1. So, now, the values of Qn and Qn plus 1 is 1, 1. And after that, we have to decrement SC counter. One step is done. So, we decrease. So, SC minus 1. 4 minus 1 is 3. Alright. So, now, what do we get? This 1, 1. So, check. Next value is 1, 1. Alright. So, go back to the flow chart. And here we have, if we have 1, 1, that means this arrow. Okay. So, here we don't have to do minus or plus. We have to just shift. So, we will do that shifting now. Alright. So, here nothing. No plus, no minus. Just shifting. So, that is why arithmetic shift right. Alright. So, now you are aware with this shifting. So, we'll shift. Again, concentrate the first place. See, this is the last shifted value. We'll take that and further shift it. So, the first value will occupy the first position as well as shift towards 1. Then this, I'm sure you must have understood. It will shift and the last value will go across. Alright. And so, this here now is our new Qn and this is our Qn plus 1. So, our shifting and new value of Qn plus 1 is generated, and then decrement SC minus 1, which is from 3 it will come to 2. Okay. So, our next value to be considered is 0, 1. So what do we do when we have 0, 1? Let us check the flow chart. 0, 1, that means plus this side. Okay, plus and then shift. So we'll do that. Okay, so 0, 1, and this time we will do add, straight add. So we'll take the value, last value of AC, last value of AC is this, and then BR. BR is this. Okay, oh, so sorry, BR is this. So we'll take that 0, 1, 1, 1. So you've taken that. Simply add. I hope you all remember the addition process. Okay, 0 plus 1, 1, 1, 1. So here 1, 1 is 2, and 2 we know, 1, 0. 0, 1, 1 plus 1 plus 1 is 3. 3 equivalent is 1, 1. So 1 here, 1 carry up. 1 plus 1 is 2, which we know is 0 here, 1 carry. Okay, you may have your own method of addition. You can apply that and check the value. Okay, so we get 1 carry here. So because it is carry, we will discard that carry. So that is why I have circled it out. And then we get the new value in AC after adding these two. Okay, and we know after addition, we have to do shifting. All right. So this is our last value of QR. We will shift. So again, the first value will stay here and also shift at the same time. So shift, 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 and this will go across. New value of Qn and Qn plus 1 after shifting is 0, 0. Okay, and 0, 0, and then what is this? SC is equal to SC minus 1. So from 2, it will be 1. All right. So then we have 0, 0. So come again, 0, 0 this time, Qn and Qn plus 1. And 0, 0 we all know. What do we have to do? In case of 1, 1 and 0, 0, no addition, no subtraction. Okay, it is just shifting. So we'll do shift again. Okay, so here shift. So directly shift, arithmetic, shift, right. Whatever was our last value, we'll shift it. Okay, I'm not explaining, I'm sure you've understood. 0 goes to the first place, then second, then shift, shift, shift. Then this will go across, okay, and then decrement the value. And this time last value was 1, this will be 0, and then stop. Then we'll not consider anymore the values of Qn. Okay, so we are left with this new value of AC and new value of QR. All right, then time to stop because we have reached count is equal to 0. Count is equal to 0, stop. This is how we have reached count is equal to stop. Now where is the product? Okay, so product, that is the answer of this 2, the multiplication of the two values. The product is actually the combination of AC, the last value of AC, the final value of AC, along with the value of QR. And that is 0, 0, 0, 1, 0, 0, 0, 1, 0, 1. Okay, so we have ignored the previous 3 zeros, and this we have simply written 1, 0, 1, 0. This is this, okay, don't get confused. 1, 0, 1, 0, 1. And to check whether this is correct or not, 7 into 3 is 21. Okay, so we should get 21. That means the binary equivalent of 21. All right, so our binary equivalent of 21, if you check, I've done it for you rough. If you see, you all know the process very well. I'll not explain. Okay, this is what we get, and the value, the equivalent of 21 is 1, 0, 1, 0, 1, which is exactly what we are getting after this. Okay, so this is how Booth algorithm helps us in multiplying two binary digits and getting the product in binary format. Okay, so the flowchart steps, I hope it is clear. Okay, we have to check Qn, very important, Qn plus 1, what is the value? If it is 1, 0, then minus, and for minus again you have to remember 2's complement, okay, which we get with the help of 1's complement plus 1, and then 0, 1, no complement, no nothing, just we add. And then if the values are 1, 1 and 0, 0, we do nothing, no plus, no minus, just shifting. And this we carry out till we get the value of count to be 0. Okay, so quickly look at this. Because it is 1, 0, so that is why we do that minus, and for minus we have to do this complement thing. That is why this thing is carried out. Okay, you can check with your own values also how to find 2's complement, 1 complement. I have already taught you in our first chapter. You can refer to that. Okay, and then it will be more clear to you. All right, so this complement, I'll repeat, 2's complement that we get by First finding 1's complement, that is reverse of whatever digit you have, 1000 plus adding 1, that will be the 2's complement. And this is the answer. Okay, so this part is 1001 plus AC. AC is 4 zeros. So this is the only lengthy part. Otherwise everything else is simple. Just add, shift, okay, and after shifting check the value of Qn, the last bit of QR, and this Qn plus 1. All right, so very, very simple. I'll give you the theory, the note also. Go through the note and you can check this example. This is for a multiplication of two positive numbers. I will provide you another example in which I'll be considering negative numbers also, which is again very similar. Okay, so all the best. Concentrate properly. All right, and study hard. Thank you.